This is the way. This is the one we're talking about. This is the one we talked about yesterday or last time. This is the one we're going to talk about towards the end of the chapter. And guess what? Guess what? Guess what? Guess what? Here is pretty much the start. Here's pretty much the deal. Most of the time, we start here and go this way. Sometimes we have to turn around and use the slope formula first to determine the slope. And then we turn around and we go that way, okay, with the information. And we'll dig into that in a bit. But I do want to tell you that when you get to this notes, do this quiz. Got it? Do the quiz. All right, let's dig into the notes. Here we go. Point slope form of a linear equation is this guy. How does that come about? That it actually comes about when you take the slope formula, the ratio of the change in y's over the change of x's, and manipulate it a little bit, and it cranks out and turns into that thing. And it becomes a formula for a way of relating x and y, relating the points on the graph of the line, where they show up, what they do. That's the dealio. Okay, so to understand this, let's just start graphing a line. Here's an example. We're going to graph a line using 0.3, -2. Drop the point. Then remember, we're going to get from one point to the next, we can use the slope. Those are the directions. This would be up 1, right 4. So we go up 1, right 4, 1, 2, 3, 4. Drop a point. That winds up being our equation of our line. We can use the ruler to actually graph it. So that becomes the graph of our line, the picture of the equation of our line, the visual representation of these aligned with these two characteristics. We can also turn around and we can get the equation of that line using our point slope formula, using this guy. And yesterday, when we were talking, last time when we were talking about using the slope, I said start like this when you're using the slope and then drop things in there. This one, until you memorize it, I would suggest to write that down every time. I would also suggest to just go in right to that spot, okay, when we deal with a point and a slope. If we can find a point and a slope of a line, we can use this to write the equation of the line, okay? So here we go. If we dump this in, if that's then x1 and this is y1, and we dump those into the spots, we get 3 there, dump this into the spot, we get 2 there, and we have the m kind of hanging out there, and we'll drop it in. Now this is this point slope form or the equation of the line that has those two characteristics. Now we can turn around and do it with number 2 as well. We can graph them to get an understanding of what the picture looks like, and then we can turn around and write the point slope equation of point slope form of the equation of the line. So 0, 1, whoop. Slope -6/1. So we can go down 6, 1, 2, 3, 4, 5, 6 to the right 1. That becomes 2 dots that allows us to draw an example of what the picture of the line actually looks like. Now we can turn around and we can take this point and that slope and we can drop it into point slope form. This here, Bella. Again, as you're going about memorizing it, you can just take these, drop those in right like that. Mark these, x1, y1, drop y1 in there, drop x1 into there, and drop our slope into there. Now we don't ever leave 0 when we're dealing with, we try to simplify it as much as we can, at least the first step. That one right there would represent the point slope form of the line. And what's interesting is when it's in point slope form, we can turn around and we can actually see the point as loaded right up into that action, okay? And we can see the slope, this ratio, right up into that action. Same thing here. There's the slope, again, hidden here. The x is hidden in there, -0, and the y is hidden in there. All right, now if we turn around and write the equation of the line in point slope form, drop this action down, drop this action down, and put some things in there. We're going to mark this x1, y1. M is already noted. We're going to turn around and drop those into their spots. So y1 right there, so we're going to drop 1 there, x1 right there, -3, and -2 comes from the slope. Now here we have a situation where we have a minus minus and we don't leave that. Okay, this winds up being the equation of the line. It's like a nickname for the visual representation of the line itself, one of the nicknames. There's other forms we talked about up in this action. Right. Ooh, find you. Where'd you go? Where did I write you? I don't even know where I read those. But anyways, another equation of the line, like slope-intercept form, which is what we talked about the other day. Here we go. All right. Now, what happens if we are given the equation in point-slope form and we want to turn around, describe the characteristics of it, like looking at the equation and finding a point that's on the line, or looking at the equation and finding a slope that's the slope of the line, and what happens if we want to turn around also and graph it. So we can look at the equation and find the characteristics. If you remember, point slope form is this. Okay, your slope's going to be m, so it's whatever is written up. So it's 1/4. That's where we're supposed to write point. That is 1/4. Okay, so that's our slope. Now we need to look at the equation and find the point. What is fancy about this is notice point slope form has a minus there, but in this way it's written, there's a plus. We want to make sure to do the opposite of that, right? Because if we turn around and actually make it look a little bit more similar, we do minus 5, you can see that now we have a minus, now we have a minus. So the x-coordinate of the point is actually -5, okay? Not +5. And we have a 1. So now if we go ahead and graph it, we actually don't need the y-intercept to graph it. We could use that point, -5, 1. -5, 1. That becomes our new starting point that we go from, and we use our slope to find any and all, or not all, but another point that is also on the line. So up 1, 1, 2, 3. To the right 4. Drop some ruler action in. There we go. That is the picture of our line, or the graph of our line, who has this as point slope form of it, one of its nicknames. Here we go. Let's do another one. A little bit different, a little bit weird. Remember, we've got y minus y1 equals m parentheses x minus x1. Notice our m is the thing out in front of the parenthesis if it's in point slope form. That's a negative. It's just a negative out there. So that's actually a slope of -1. You could view it as -1/1 to figure out where to graph it. But also you can turn around and read the point. So point, the x goes with the x, but we have the reverse sign. So it's not -6, it's +6. And over here, it would be -2. So the y coordinate is -2. Now we're going to turn around and graph that. 6, -2. And we're going to go down 1, right 1 for our directions from that point. Notice how we started at a different point. We did not start at the y-intercept. We started at the point that was given to us as it was written in point form. Here we go. Here's another one. Point being, ooh, this is weird because there's nothing out there in front of the y. Remember, it's y minus y1, m x minus x1. And notice m, dropping that 3/1 by the ways. Or we can read the point being minus, so the x-coordinate would be -1, and the y-coordinate is not out there, but it's 0 if it's not written right there, because y minus 0 is just y, and then we're good, and then we have the minus thing in there. All right, now we have a new starting point, -1, 0. We use our slope from that 1, 2, 3 to the right, up 1, 2, 3 to the right. And we go ahead and we graph this. All right, let's go to the next one. One more. Now we can drop in a parenthesis there, right, -0 to help us read it if you would like. Okay, slope -1/2. I like to put the negatives on the numerator because I always go up and down or to the right. I don't go to the left unless I run out of space on the graph. Anyways, so 0, 9 would be the point. So 0, 9. We go down 1, right 2, down 1, right 2. Graph that. What's interesting is that starting point just so happened to be our x-intercept or y-intercept rather. That's it. By the way, there's something called the x-intercept to be the thing where the spot where the graph crosses the x-axis. BT dubs. All right, here we go. Write the equation of a line. We've got 2 more deals here. And we'll do those on the next video. Peace.